I'm Andrea and I'll be presenting on uxSense, supporting user experience analysis with visualization and computer vision, which I co-authored with Yipeng, Mingming Fan, Jian, Zhao, and Niklas Elmqvist. We identified 3 challenges in UX evaluation. Qualitative evaluation is often required for nuanced interpretation of complex user behavior, and multimodal data is often collected during user sessions. For example, a study may call for the collection of video, audio, clickstream, survey response, and open-ended interview response notes by the interviewer from each session. So both the object and the measurements are time-consuming to evaluate, and evaluation does not scale very easily. So there's a need there for tools to support this kind of evaluation. And before we developed uxSense, we had to consider the design framework we'd be working from. We had 4 design requirements. First, we felt that we needed to identify key moments throughout the session that would be potentially significant to the UX researcher. And second, we wanted to support the UX researcher tagging segments of the user session and to annotate different points of the session, and then use that information to generate reports about the session. From our multimodal data, we want to extract relevant features and present them concisely to the researcher. We want to support exploration of multiple concurrent streams of the multimodal data, such as pose or the actions that the users are engaging in. We want to include the user's facial expressions and also features of their speech. And we want to support the following workflow. First, the user uploads video or audio recordings to the system, which should then compute filters to extract features, and allow the user to monitor and update their view based on the extracted features, while analyzing the multimodal data from the session. Finally, the user should be able to generate a report based on their analysis. So let's talk about the system. We created a visual analytics system, uxSense, that puts a computer vision for HCI, for scalability, for qualitative evaluation framework into practice. It takes video input, applies machine learning models or filters to it, and presents the user with a visualization interface with information about the user's sessions. We detect 3D pose as input variables for change point detection with the eDivisive measure, which we use to temporally segment the frame intervals prior to processing via pre-trained semantic labeling models, action classification, and emotion classification models. This project was intended to be mainly for originally evaluating immersive environments. We soon decided it should be broadened to any type of user session, including desktop, for a final version of the paper. We segmented based only on joints that included the user's head position. Finally, we incorporated speech recognition and audio features, as discussed in Fan et al., to create transcripts and representations of speech rate and vocal pitch. The main components of the UX interface itself were the video playback, the transcript output from the Vista elements, an annotations table, and a timeline viewer that can be annotated by the user. The transcript was one output from the models we used, while the remaining outputs were all used as timeline visualizations in the bottom component of the interface. The timeline viewer also rendered a view of the user annotated points and intervals, which could be previewed with a mouse over tooltip. And the user could then generate annotlets, which are micro report elements that are PDFs or SVGs that can be inserted in other documents, or images that can be inserted in other documents. It's really comprised of a chunk of the timeline that the user annotated, a transcript snippet from that time range, and the user's notes, their annotations. So we conducted an expert review with uxSense, and all participants held positions with the title UX designer at varying levels of experience and held advanced degrees, or at least in the case of one participant, a bachelor's degree. The sessions were over Zoom and about an hour long. They started with a free-form training phase, followed by an activity phase in which the participants had to identify user experience problems in a sample Tableau user session video and summarize their observations at the end of the activity. Throughout the study, the participants were asked to engage in Think Aloud protocol, and after the session, they were asked to complete a post-session survey with open-ended text response questions and with Likert questions derived from the NASA TLX, which all participants returned within a week of the session. Participants self-reported having spent the most time in order of most to least frequent in the session video, and then in the transcript, then in the timeline, then the annotations table in that order. Of the timelines, most of them mainly used the emotion timeline, although some of them did use the annotations and semantic action label timeline. On the bright side for uxSense, participants found the system relevant to their typical workflow, easy to learn, and that they could use it to accomplish the task they were asked to do. On the downside, they found that the timeline visualizations were difficult to interpret. They felt rushed completing the task. They found the interface a little unpredictable. They were, and in the responses, they were mixed positive and negative results regarding how demanding, enjoyable, and frustrating it was to use uxSense to complete the tasks. In the paper, we summarized participant responses to open-ended questions, but I'll limit my discussion of them here to the proposed changes to the system based on their responses. Participants expressed a need for exportable features like analysts and data subsets. They couldn't export the data in the existing implementation. They also felt the need for speed controls for the video and resizing options for all elements of the view. And they discussed the desire for better signifiers of affordances, including more use of icons, tooltips, and pre-selected intervals for enhanced user guidance. Finally, they felt that there would be value in session comparison utility to support qualitative pattern identification. And that is all for this talk. Thank you for listening.